to know how do some of the things in the states of matter or law of conservation of mass relate to what we just learned about Dia de los Muertos. Michael, go ahead.
The solid was the skeletons. The liquid was like the girl's tears when she was crying. And the gas was the air, I guess.
Okay, good. So he gave a few examples of what the solids, the liquids, and the gases are. Let's hear from... Okay, well, that's good. Let's give other people a chance, too. Anidra.
For the solid was the tombstone. And
Okay.
the gas was the light, like the energy that was coming from the light.
Okay.
And the liquid was the molecules.
Okay, so maybe some of the actual molecules within that liquid. So, okay, so that was table 5. Makina.
The solid was when she was first at the cemetery visiting her mom's grave. She was just sitting there not doing nothing, and then when she got into a dream, that was kind of like a liquid, because she wasn't very moving a lot. And then when like almost at the end, she was moving very fast and like a gas all around.
Okay, awesome. So that's like the different energy levels, right? So Makina was saying she was kind of still at the beginning, not moving a lot. And we know with the molecules of a solid that those are really tightly packed. And then she said when she went to the underworld to see her mom, then she started to be more like a liquid. And then by the end, she was dancing and moving, so it was like a gas. Okay, so let's hear like a little bit more about the states of matter. But I really want to know, how does this relate to the law of conservation of mass? Someone think they can answer that? Cameron.
Probably because, like, the law of conservation of matter, like, I guess, like, you know how whoever died, even though they died, they'll still, like, they don't weigh any less because mass cannot be created or destroyed.
Perfect. So what can happen to their bodies though? So if we're talking about the law of conservation of mass, what can happen that allows that mass to stay the same even if they do pass away? Christiana.
Well, I would say it connects to the law of conservation because when the person dies, they can't be recreated.
Okay, good. So they can't just be destroyed, right? They can't just go away. So something has to happen. So Asia, what is something that happens to them?
What was the question?
So we're talking about like what happens to someone once they die. So we're talking about how energy cannot be created or destroyed, right? So what is something like, how can something break down?
Like some people say, who were made of dirt, so some people get buried, they decompose and turn back into dirt.
Perfect. So their bodies can decompose, right, and turn into something else. Let's hear from someone we haven't heard from. Anthony.
Not a flower water down, and then not a gravity. When you jump and you fall back down.
Mm-hmm.
Yeah. When she fell down, the gravity had pulled her down.
Okay, good. So the energy was still being conserved, right? Okay, good. That's a good example. Michael, what do you want to add?
Okay, like when you say like mass can't change, like it'd be the same. Just like when she went down up in the underworld and saw all them skeletons, and then at the end, it was probably fake, but the mom came back like she had her skin. Like the skin don't add on to the mass of how the bones weight, so like I guess she like stays the same as her mass like before she had the meat on her.
Okay, good. Asia, you want to add something?
When she went to the cemetery and the part that I understand about mass and conservation, your reaction equals your product. So when she was at the cemetery, her reaction was her skin. She still had her skin, and when she went to the underworld, and then when she came back out, she was still her. She was her product.
Okay, good. So Asia was talking about those products and those reactants. She said that the mass of the reactants put together equal the mass of the reactants. So good. Awesome. Who haven't we heard from? Who hasn't talked? Let's see. Anidra's talked a little. Jayla, go ahead.
Where the conservation of mass is that, like the helium in a balloon, where everywhere where she had fell on it,
when they had popped the helium out the balloon had traveled around the area.
Okay, good. So remember that gas never goes away, right? And what kind of a container did that gas take? Can anyone tell me? Michael.
You said, wait, what's the question again?
So what kind of container did that gas take?
What gas?
The gas from a balloon.
It's like any like shape of the container.
Okay, good. So if we let it go in this room, it's going to fill up all the space in this room. Or if we make it go into a balloon, it'll go into a balloon. Do you, Anidra, you want to add something?
For the conservation of mass, like when the skeletons, like when they turn into ashes, the mass of the ashes is still going to weigh the same as the bones and the skin together.
Awesome. So she just gave a really, really good example. When you guys were doing your centers and you guys had to research like some real life examples of the conservation of mass, some of you guys came up with a paper burning and then the ash and then the gas released from that is equal to the original stuff. And Anidra said kind of the same thing, right? That those ashes are going to equal their weight of the original mass, even though some of that gas is going to go out too. Cameron.
Like when in the video the liquid it was her tears when she was crying about her mom. The solid was when the flower like when it came to kitchen like the skeleton and the gas was the air that she had breathed.
Good. Michael, you want to add something?
Yes.
Go ahead.
Just like when you was teaching us about like magic ain't real. Like you can't pull a rabbit out of a hat. A flower can't just go out the ground and pull you into the ground. That's like magic. It can't happen.
Okay, good. So something like that can't happen, right? We have to have, nothing can just be created. It has to come from somewhere. Asia, you want to add something?
What was the question again?
You can just add to anything. We're just talking about in general about states of matter, about the law of conservation of mass.